Hello friends, welcome to my channel Physics with Rakshit. So in the present video, I will explain quantum measurement paradox or measurement problem, which is one of the unsolved problem of modern physics since its establishment. Let us see what does it mean. According to this problem, interpretation of quantum mechanics doesn't allow definite outcome to be realized. It means that in wave mechanics, superposition of waves are included, while in quantum measurement, one definite value is required. So these both branch contradict each other. Another reason is because of matter, duality of matter and radiation, this problem is arised. So, to explain this problem, let us consider one experiment, that is Young's double slit experiment. This experiment was performed by Thomas Young in 1802 to prove that photon is nothing but wave. In this experiment, as a source, photon gun is considered that emits various photons. These photons will firstly pass through one slit, which will make them in phase. Thereafter, these photons will pass through two slits. Because of passing through two slits and at the screen, because of the superposition of these photons, we will have brighter and darker fringes. As we all know, because of the superposition of two or more than two waves, we will have interference pattern. In this case, we will have brighter and darker fringes of interference. So this was the experiment to prove photon behaves as wave. Thereafter, de Broglie gave hypothesis that matter having wavelength. So in 1961, another experiment was performed to prove particles also have wavelength. In that experiment, we have considered electron gun as a source of electron. This electron gun will emit electrons, which will in turn pass through two slits. Because of the superposition of waves of electron, we will have brighter and darker fringes on the screen because of the interference. So similar to this experiment, here we have considered electron. So here let us consider some cases. For example, if we close one of these slits, the interference pattern goes away. It means though we will have brighter spot at the center of screen, but interference pattern goes away, because here by closing one of the slit, superposition ceases to exist and thereafter interference ceases to exist, and that is why we will get only one brighter spot and on the center of the screen. Second case is if we put a detector near either slit or screen, interference pattern goes away. It means that measurement affect wave nature of given particles. According to uncertainty principle, we cannot measure two quantities simultaneously. For example, whenever we try to measure a particle precisely, it means we want shorter wavelength photon or a photon with higher energy. These photon will collide with these particles and it will transfer some of the amount of momentum to this particle. Ultimately, it will affect its momentum. So we can measure its position precisely, but we cannot measure its momentum. So here we can say that measurement affect the wave nature of given particle. And to explain matter having wavelength, it means wave nature of particle, we require newer branch or newer explanation, and that explanation was given by Schrodinger in terms of this equation, which is h cut square over 2m del square psi is equal to minus I h cut del psi over del t, which involves wave function. Wave function is nothing but representation of probability of particle will be in given position. So according to Schrodinger equation, we cannot find particles position precisely similar to classical mechanics because we are involving quantum mechanics. So here, according to wave mechanics, interference patterns also have probability. So because of all these reasons, measurement will affect wave nature of given particle, and that is why in quantum mechanics various interpretation of quantum mechanics doesn't allow definite outcome to be realized at microscopic level. This is the definition of measurement problem or quantum measurement paradox. While in classical mechanics it was possible, in quantum mechanics it is not possible. In my next videos we will see various interpretation of quantum mechanics through which we can explain the strange behavior of quantum mechanics and how we can eliminate this problem from quantum mechanics. Still, many physicists believe that measurement problem is still unsolved in physics. There are several interpretations of quantum mechanics. For example, Copenhagen interpretation, hidden variable, many world interpretation, consistent history, relational quantum mechanics, etc. Each will define measurement problem and try to solve measurement problem in their own way. But still this problem is open for all. Thanks for listening and watching. If you have any question, you can ask in comment section. Thank you very much.